Data science is in huge demand across all industry sectors at the moment.
Business leaders like to visualize things and make sense of this data.
This course will be very, very exciting for anyone who has intrinsic interest in mathematics and some element of computing at the school level. Students at Singapore will have access to a global network of knowledge. All our projects involve partners and technology that are globally relevant.
The skills, combinations of mathematics, statistics, computational, and another area.
We have lecturers, researchers who have experience working in the industry, and we constantly collaborate with industry partners.
The future of data science, of course, is very bright.
Welcome, my name is Chin and I'm pleased to welcome you to our info session on the Bachelor of Science, Data Science program at Curtin, Singapore. Now, this is the second online webinar of the series on program info session of Curtin, Singapore's new bachelor degrees in Information Technology, Data Science and Cybersecurity. This series aims to provide you with key information about our programs and for you to find out how you can future-proof your career with a degree from Curtin University. In this webinar, I would like to thank you, our participants, especially those returning to this session from last week, and our speakers, Dr. Ritu Gupta and Dr. Suman Rashid, who are dialing in with us from Perth, Australia. Just a little housekeeping before we get started. If you have any questions during the session, please click on the Q&A button on the bottom of your screen and type in your questions. I bring them up at the end of the session and we will have time for questions and answers. Without further ado, I will now hand over to Dr. Ritu Gupta. Our speaker today is Associate Professor from Center for Optimisation and Decision Science, School of Electrical Engineering, Computing and Mathematical Sciences, Faculty of Science and Engineering at Curtin University. Dr. Ritu Gupta, over to you, please.
Your volume, Ritu, your volume is...
Welcome everyone to the session on Bachelor of Science, Data Science degree offered by Curtin University. So in this session, I will present to you an overview of what data science is and what we offer here at Curtin. So I'm the associate professor here, and I'm also the course coordinator for data science and also member of the Curtin Center for Optimisation and Decision Science. And I'll tell you more about the activities of this center a bit later. So we are part of the School of Electrical Engineering, Computing and Mathematical Sciences. And we all sit under Faculty of Science and Engineering. So first of all, I think you all are attending this session, so you have some conception of what the data science could be. So may I all request you to all fill in a little poll on that will appear on the screen and fill in all that you think are components of data science. So just your view of what you think data science components are. Okay, so note that you can select more than one choice here. Okay, so let's see what are the results of our poll. Yes, I see most of you, almost everyone said that it has an artificial intelligence and machine learning as its components. Yes, that's absolutely right. It has mathematics and statistics. Yes, that is also absolutely right. The coding and business data processing. So let's close the, so in fact, you all these things, artificial intelligence, machine learning, mathematics and statistics, coding, everything is a part of your data science journey. Business data processing is a specific application of the data science that is applied to the business settings. So what exactly is a data science? So the data science is a term that was coined in 1974, but has been more in the media and discussion over the past 2 decades, just because we are able to collect vast amounts of data and we are able to process this data also through massive computing power that we have at the moment. So a data science is just a science that deals with the huge volumes of data, and using modern tech tools and the techniques, we can discover the unseen patterns and we are able to make some meaningful decisions. So in view of this, we do teach in data science, a lot of computer science is integral part of it, and so is maths and stats, where we teach you how to make meaningful decisions and find the patterns. Further to the data science is a domain knowledge. So through domain knowledge, we mean that the application of that you are going to explore. For example, you will be studying a business data to find what is the best portfolio of shares that you can have. You may be designing a helicopter and you may be designing the components of it or the design of it. You may be diagnosing the risk of getting a heart attack by looking at the CT scans. So that is the domain knowledge that you need to acquire. Or in some cases, you may be using data science to predict which team is going to win a particular match or sporting teams. So data science is a combination where you pick up a domain knowledge, you apply your computer science knowledge and maths and science, and come up with a decision-making tool. So a modern data scientist is not someone who will be hiding behind a computer screen and doing coding all the time. Yes, mathematics and statistics, programming, coding will be an integral part of your daily work life, but so would be the other parts, which is developing the soft skill, understanding the domain area, if you're working with a business application, talking to the people for whom you're working. If you're working with the doctors, talking and communicating with the doctors to understand the problem in hand. And on top of that, you will be involved in communicating and visualization. So you have developed a complex piece of work, and that complex piece of work needs to be given to your managers or the users as a tool that they can use, which is easy to understand, which has visualizations and which has pictures, and you need to be able to tell a story for all these things. So a modern data scientist will involve all these components of study, and this is what we address here. So when you come to study at Curtin University, you will be heavily engaged with the experiences of the industry partners. So this Curtin University is the most industry embedded university in Western Australia. By this we mean is that our industry partners will actually present lectures in most of the units and in our courses. Not only that, they are engaged in supervision of the student projects. They provide work experience opportunities to our students, and this ultimately leads to the employment of the students at the end. They are also, industry partners also sit on advisory board for different courses. And so they ensure that what we are teaching is actually aligned with the needs of the industry. So the example, these big logos that you see on this side of the screen are just example of very few of the industries that we are actually working with. So BHP, Rio Tinto, Alcoa, Linus are all minerals and mining engineering. Woodside is one of the oil and gas here. Global Grain Handling Solutions is our agricultural industry. And then we have all these automobiles and fleet cares type of industry. And we do a range of projects with the government as well as the Department of Defense. And depending on the year, depending on the projects, these all companies are involved in offering projects for the students, which could be a short duration project or long, 1 year long projects. When you come to Curtin University, you will be exposed to a very, very rich landscape of data science activities that happen on the campus. So we have the data science, first of these is the Data Science Innovation Hub. So this hub is being set by a government on our campus. And the aim of this center is to bring together the community, industry, academia, and government. So this center offers a lot of training to the academic staffs, the industries, and also to students. The center is also organizing, say, a conference in 2 weeks' time where students are given special trainings, etc., on the data science methods, and also they have opportunity to meet the industrial partners and leaders. We also have on campus the Data Science Transforming and Maintenance Australian Government ARC's Center. And this center directly liaises with the industries, and they perform or they advise industry on how the data science can be used for transforming maintenance. Say, for a very simple example, could be that you could do a periodic check of oil of your car, and we can give you a model to say that if this is the condition of oil of your car, that means your car may have a catastrophic problem. So it's better you get it fixed. So these concepts are applied in the mining centers. We also have Innovation Central Path. This is again trying to solve really complex industrial problems through research. And students again have opportunity to participate in the activities of the center. We also have Curtin Institute for Computation. As you can see, that computation is the core knowledge or the core or the backbone for all the data science type of applications. So the Curtin Institute for Computation is solely dedicated to creating the models and handling the computational aspects of and the visualization aspects of all applications and providing research support to all the activities that happen on campus. We also have Curtin Center for Optimization and Decision Science here on campus. And this center's role is to deal with very complex mathematical and statistical problems that require a data-oriented solutions. So how do these centers all help you or integrate with the data science degree on campus? Is that all the members of our department who are involved in the data science teaching are members of these institutes and are involved in the activities of these institutes. And in that way, we are the staff are actually engaged with the industry activities, and this fosters the industrial collaboration into our teaching. It we have access to invite people to present lectures on specialized topics and supervise and offer specialized students projects. So what you see here is the students who are in this picture who are at our second year level, and this is one of the activities or hackathon they participated and did really well, where students all over the Western Australia were invited to the team and participate. And we have many such activities that students can actually participate in. So what does this degree structure looks like? So in simple words, we have 6 blocks, 6 different blocks of teaching, and that is maybe presented as a trimester at Singapore. So this first 2 blocks that you see here, this unit in the green is the basic communication unit, and this one is your probability and your data analysis unit, which is the fundamental of mathematics and statistics. And then you have a range of your computing units as you go along. This is another of the statistics units. As a data scientist, you have to know a little bit, a fairly good degree of mathematics, which is being covered in this unit. So once you have covered these 2 blocks of 4 units, you are now ready to learn more about complex problems in the data science. So this is very much like a foundation year. Then you go to the second year, we do some more specialized units like computer simulation, where you learn how to create an actual computer model of some physical process. And in these kind of the units, you learn more complex process of decision making and the visualization. So, sorry, I just pressed something. And in all these units, data security, you learn about how to keep your data, how to acquire the data, and how to keep your data very secure. Most of the students at the end of this point are now ready for an internship or an industrial experience. They have the foundation and the background to move with. And as you move to the year 3, you actually have more information, or you're taught about more advanced data science concepts and experience. Of all these units, a few things that are worth pointing out. One is the industrial project. So this you do in your final semester of your study, and this is the place where you actually engage with your industry partners, and that I've explained to you before or shown you a few examples before, and we give you an industry project to work with. So you may be working directly with the industrial partners on a real life problem that you need to solve, which will involve everything from the collection of the data to actually finally implementation of the models. Along with your data science study, as I said, that you really need to have a discipline knowledge. For this, we have 4 different green dots, which we call as electives. And depending on your interest and the choice, you can actually pick up electives from across a wide range of studies that are being offered at Curtin. So your electives could be like, if you want to study the data science applications in astronomy, maybe you want to study some physics. So you can pick up physics as your electives. If you want to model the water quality in Singapore, maybe you want to pick up chemistry as your electives. And those of you who like music and art, you have options to pick up art and languages as your electives as well. Those of you who only like mathematics and statistics, well, you have the option to pick up your advanced analytic units like optimization, supply chains, geographical information system, etc. So this is the basic structure that we follow. And as of from the next year, you are able to package this structure into different majors or specializations. So you can pick up the data science major and you will be able to combine it with different other majors like mathematics, software development, information technology, agriculture, physics, chemistry. So this becomes your total package of your Bachelor of Science, data science. You can also, if you want to diversify your experiences, you still want to keep the data science major, you can mix match this with different streams of specializations. So one of the specializations that we offer is statistical sciences. So you are specializing in creating your statistical models. And then you can again mix match with your elective study. Do you end at the data science, Bachelor of Science? Quite a lot of our students actually after Bachelor of Science want to go and work, and they are actually snapped up by the industry. And some of them actually want to upskill themselves and go to the honors levels or go and study masters and PhD. So that kind of the pathway is also available at Curtin. And you can do the masters by coursework or masters by research. And if you get fairly good honors results, from honors, you can straight go and do a PhD where you can investigate a problem of significant complexity and challenge. So what happens at Curtin when you study? You have really dedicated staff who are actually approachable. Our student satisfaction rates are quite high. You can write staff emails and they will respond as quickly as possible. All the units that we have discussion boards where you can go and post your problems and they are actually answered, and there are consultation sessions with the staff as well. We also have a community of the students that help each other. So we have student bodies or student clubs, and these clubs also organize student help sessions. We also have special clubs like UniPass, etc., that have help students study the units, which is usually for the first year levels when the students are transitioning from school to the university. This degree has recognition by industries in Perth around Australia, because most of the staffs are actually collaborating with other people in Australia and around the world. And the biggest emphasis is that our courses are actually up to date, and we regularly take feedback from industries and update it. Say, for example, just now we have introduced, we'll be introducing from next year onwards, Databricks environment for cloud computing because of the feedback from the industries. And most importantly, our students are industry-ready graduates. So they have not been taught only the subjects, they have been taught and about how to work in the industry as well. And throughout the degree, as the time progresses, as you study and move to the higher order units, you actually understand and develop more skills as you go. So now, moving forward, I thought I'll bring to you 2 examples of the projects that are completed by our students. And these projects were completed by our students in their final year of study. And these projects will give you an idea about what kind of industrial experience our students get. So the first of this project was a student project where the student was working very closely with the Western Australian Department of Police. Now, these numbers are not the real numbers. We've just put in some numbers just for the purpose of demonstration. So the Department of Police came to the university with a problem of resourcing. So they wanted to know that if there are certain number of incidents overnight in the community, which of these incidents are the most significant incidents or most important incidents that need an immediate attention, or which of these incidents can be explored later in the day. So what the problem was very, very complex, because overnight you may have large number of incidents, and incidents may be of different types and different classes. So the job of the student was to actually sit with the police officer and see that how the police officer would actually go and rank those incidents, what goes on in the brain of a police officer. So the student actually interacted with the police officers and sat and understood the whole concept behind how the police officer will go about with the process of ranking. We collected the data back on the process, and we created a model, a machine learning model based on a technique called Bayesian methods or Bayesian belief networks, and we created a model. Now the model looked very, very complex, but so how do we make it usable for police? So we took this model and went through a deployment stage and created a dashboard using our technology. And here we have a working tool for the police, and the police is definitely using this at the moment. So every morning, the data is extracted from different resources. So there's an automation process. It is processed into a system. And through this dashboard, we set up an indicator, which is 65. So any incident which gets a score above 65 is actually being regarded as a significant incident and needs an immediate attention of a police officer. So this is a kind of a piece of work that is done by students as you are completing the degrees. Now, this concept is a new concept, and this has now been used by police even to rank the missing persons report or missing persons reports as well. And there's some further work being done in these projects, which will be carried over through other projects and higher through honors and PhDs, where more complexities of these models is being looked at. In the second example is from the WA Super. So this is a superannuation which exists in every country. So this is the kind of the money that you put aside when you're working, and then this money is used by the government to support you in your retirement age. So I'm sure in Singapore, this might have a different label attached to it, but it is. So this project was taken up with a student with some knowledge of, with interest in the business side of the things. And the objective of this study was for students to go and give early warning to the organization that provided the data, WA Super, regarding the clients who are more likely to leave. So usually in Australia, the clients may actually leave your super fund if they get an employed elsewhere and the employer has their own super fund that they prefer, or they may just between the super funds because they want to optimize their gains. So the first biggest problem for this student was actually to understand how the super fund operates, what are the different sources of the data can be, and even like the WA Super people were thinking that maybe before people switch on, their online activity increases. So the student collected the data from a vast majority of resources, and then the data was together. And this model that you see in front of you is an example of a machine learning model, a decision tree. So if you see more of the white spaces, that means this person is likely to stay. If you see more of black in this bar, that means the person is likely to leave. So we start with all the variables, whether the person has a benefit or not. If he has a benefit, then you go down the decision tree branch and you're able to make a decision. So this was very complex problems. The data set was extremely huge. And in addition to this machine learning, the tree that I showed you, they used more advanced methods as well. And now we are in a stage where this model will be now moved to the deployment stage, where we will actually have a working model provided to the company and which will be tested and validated as the time progresses. So this is the short story of what the data science can do and what we offer. Now, I want you to all answer a small quiz on to evaluate if the data science is actually for you, or how well fit is the data science for you. So I'll request you will see us poll on the screen. So please fill in all the things that you enjoy doing. So please fill in and select all the options. Okay, may I have the poll results, please? Okay, so quite a mixed bag of results that I see here. So I have about 45% people who like coding but have no experience in coding, but that's okay. There's 45% also study mathematics and they enjoy problem solving. And we have a good number of people who generally have an interest in innovations like artificial intelligence. Okay, yes, and more than 50% of you like to play computer games, and very few do not study mathematics or have no experience in coding. So let's see what is out there. So if you selected even one of these options, that if you like coding, that's okay. We don't expect you to have any experience in coding. We will teach you the codings that you need to be data scientists. And if you study mathematics, enjoy problem solving, that's all. Data science is a very, very good option for you. And I can ensure that we will keep you very occupied and very happy with these tools. If you generally are interested in innovations like artificial intelligence, you like computer games, you get engrossed in the computer games for hours and hours, you like to watch all the science fictions with artificial intelligence, I would say that you have an intrinsic interest in data science, but you really need to explore the study of mathematics. You don't have to do it very high level, but at least you need to see if you can study mathematics as you move towards it, because you do need mathematics for your data science, because mathematics is an integral part of the data science. If you do not study mathematics and you have no experience in coding, you're not yet tasted data science, you're not ready for it. So what I would recommend is that you try to see if you can get some experience on coding, or at least try to understand what it entails. But more importantly, see if you can actually gain some experience in the study of mathematics, and then you can transition into the field of data science. So that's a very, very short story about what data science is and what we have on offer at Curtin. And thank you everyone for listening, and we are open for questions now.